Because if you plug the equation into the calculator and then you plug your thing, you're going to get two different answers, and then you can equal each other.
So it equals 2 and 5, right?
So I did it 2 times 20, and I broke my 20 down 2 times 10, my 10 is broken down 2 times 5. So I pulled my 2 out, but I have the 5 in, so you need to make sure that it's 2 times 3, the square root of whatever you have left in. Or cubed root in this sense.
So you put 2 and then
Times the
this
cubed
one
root,
goes in.
cubed root of 5.
Mine is like my sister's.
All right. So if you do these using method 2, that's fine. I'm going to continue to try to push you towards method 1 because people make fewer mistakes with method 1. Please don't take the person. If you want to keep doing method 2, beautiful. If that makes the most sense to you, keep doing it. But when I do these problems on the board, unless you want me to, I'm going to always do method 1. So you can just see the answers match up.
So according to the method 1, you're going to say that 15 divided by 2 is 25.
Good, so I can rewrite this as the square root of 25 times the square root of 2. Those are equivalent. And what part can I do? Square root of 25 is 5. What's the square root of 2? 1.4. No, I don't know.
Is that the first one? Oh, are you doing it?
Total.
Oh.
Now, of course, those of you that broke 50 up, maybe you broke it up as 5 times 10, and then 5 times 2 times 5, so you had 2 5s, so 5 could come out. What I get when people do it that way is I get, and I'm not picking on anybody because I know somebody did this, but I get that. Right? And that's the wrong thing came out. So I like the idea of the jail. I would probably, the way I would put the jail is there's a 5 and a 5 and a 2 in jail.
One can get out, one distracts.
These guys work together.
One distracts the car.
Yeah. There's not enough 2s to get out. You need 2. And on the way out, one of them dies. I don't know. Sure, whatever gets in your head. All right? The cube root, it's a higher security prison, so now you need 3 people to get out, and 2 of them are going to die. Whatever gets you through. That sounds like something I would teach, but I actually don't like it as much as that. But whatever sticks in your head. This one came up interesting. Let me do this not really wrong, but let me do this wrong in a way, and then I'll show you how to keep going. So some people realize 72 is 9 times 8, which is beautiful. Nothing wrong with that. Square root of 9, so that's square root of 9 times square root of 8, right? Square root of 9 is 3, square root of 8 is, I don't know, but yes I do know something, because 8 is 4 times 2. So I got 3 times the square root of 4 times the square root of 2. Is that cool? Square root of 8 is square root of 4 times square root of 2. What's square root of 4? So 3 times 2? 6. That's nothing wrong with that.
So if you keep pulling them out, you just multiply them out?
Beautiful, because this is all based on multiplication, right?
Yes, sir.
So whatever's out there is multiplying, so if something else came out, you'd multiply them together. Yeah, and if you had to keep going and keep going. So like if I said, reduce 412 over 808, you might do that in a few steps, right? I go, shit, I don't know. 4, and then maybe more goes in, and maybe more goes in, so you got to do it several steps, who cares? Same idea. Cool. Okay. Number 3 is another one where that could happen, but what's a good way to break this up?
2.
4 and 2.
But go times 5.
4 and
2
2.
times 16.
All these. Okay, well, all right. Let me do one method. I'll do one method too. Sure. 2 times 60. 2 times 30. 2 times 15. 3 times 5. All right. Now I'm looking for groups of how many? 2. Yeah, I got 2 2s.
Then you're left with
And that's it, right? So I got 2, and what's left on the inside? Yeah, 6 times 5, 30. Like. Is that cool? Alright, so anybody who thought you could do this more than 4 times 30, not really. You gotta be careful. Alright.
Can you do that with the shortcut way? So I can see it?
Yeah, so square root of 120 would be square root of 4 times square root of 30, which would be 2 square root of 30. You see why I prefer that? Just like, I always wanted to find the quickest way to do anything when I was a student. I drive my teachers crazy. And now I can drive you guys crazy. Number 4, another square root, so this should be semi-quick. I think somebody jumped the gun earlier. There it is. I was like, yeah. 16 and 5 is a good way to break that. You always think, if you want to do it this way, you always try to get the biggest square that'll work, so you don't have to do multiple steps. So 4 goes in, but 16 is better because it's bigger. Square root of 16, 4, square root of 5, I don't know. Alright, I'm going a little quick, but you guys aren't saying anything, so I'm thinking you're good. Number 5 was the first semi-evil one. Right. Square root of Larry Bird. Yeah, this has got 1, 3, and 1, 11, so I ain't going nowhere. Because the square root needs at least 2 of the same thing to be able to be done. This is not prime. Don't necessarily say prime. It's related to prime. It's just already simplified or can't be done or whatever. It's sort of like if you had 6 eighths and you made that become 0.75, technically you're right. But I normally don't want decimals unless the problem involves decimals.
So that's the answer you want? Already simplified?
Yeah. Or can't be done or whatever you want to say.
It's like a 0, all that.
It's not really a solving situation. It's not an equation. Okay. Let's see. 4, 5, 6. There we go. Now I got some cube roots. This one should be quick. The reason I threw this in the mix is just when you learn a new method, you sometimes forget that you don't always have to use that. The cube root of 64 is just 4. We know that. So I like that some of you guys went a little crazy on it, but it's just 4. Cube root of 40. Now I'm thinking cube root. So if you do it method 2, you got to look for groups of 3. If you do it the shortcut method, you got to think about what cubes go into 40. Of course, what's that?
8 and 5 and 5.
Yeah, 8 and 5. Cube root of 8 is 2. Cube root of 5 is, I don't know. And you see how that looks like 2 cubed? I mean, it's just no good way for me to be careful. It's 2. Oh, before I forget. A cube root cannot transform into a square root. Make sure that you don't lose your roots, right? They got to come all the way down. Okay. 8. What about this dude here? Yeah, 8 doesn't go into 54, so the next thing to try is 27. So that's the cube root of 27 times the cube root of 2. Cube root of 27 is 3. Cube root of 2 is, I don't know. And that just looks horrible. Alright, and number 9, I sort of gave you the answer. I mean, obviously what goes into this? 8, that's crazy. And you're left with the 111. Now, believe it or not, 111 is not prime. 1 plus 1 plus 1 is 3. So I know 3 goes into it, but 3 goes into it 37 times. And 37 is prime. So that's not going to go anywhere. Cube root of 8 is 2. Cube root of 111, I can't do anything with because there's not 2 of anything in it, or 3 of anything in this case. Okay? How we doing? Yes?
Did you ever get an exponent on the left side?
Could you? Yeah, sure. If I brought 2 2's out, you could make it 2 squared, but then you would just write that as a 4, hopefully. Yeah. Or, we had a problem earlier. What's the square root of a to the 7th? 2 goes into 7. 3 times with 1 left over. See, so you got a power. But if it's a number, don't just simplify it. Yeah. And then number 10, what's up with number 10? This is 5 times 5 times 2 times 2. There's not 3 of anything. So it's already simplified. Well, what's missing to make this happen is one more 0. Yeah. Because then there would be 3 10s. The cube root of 1,000 is 10. Because it takes 3 10s to make 1,000. But that's not what I asked, right? This problem is can't be done or already simplified.
So you can't write prime?
See, 100 is not prime. So it's related to the idea of prime, but don't say prime because it's not really true. It's not break up enoughable. Sure. I love English. It's so malleable. All right. So the last thing I want to talk about today. Make sure I didn't miss anybody. Yes.
So far we did do 12.1 and 12.2.
Yeah, and actually, this is 12.3. But here's the rest of 12.3. Yes. Hello. Hi. So, we already talked about the rest of 12.3, but I want to make it official. If I said, what's the cube root of x times the cube root of y? Yeah, that would be the cube root of xy. Cool. As long as the roots are the same. So what's the square root of x times the cube root of y? Can't do it, good. Or already done, as much as you can. Why can't you do that? Because roots are not the same. But. There's always a freaking but, right? Don't take that in. If I had the square root of x times the cube root of x, the roots aren't the same, but the bases are the same. So I can actually do something if I rewrite the roots as powers. So what's square root of x? X to the... And what's cube root of x? And then what can I do? Add those, right? Now watch, this is kind of cool. I want you to remember this. You cannot multiply things unless they have the same root. Isn't that what I just said? And that is absolutely true, period. But I'm about to multiply these. I'm about to do it, but watch what I do on the way. I love that. Don't just directly contradict yourself, man. But watch, what I'm going to do is, what do I have to do? How do I add them? I have to get... And what's on the bottom? The bottom is the root. So if I make them both 6, I have made the roots the same. I made them both 6 roots. So no matter what you do, you can't multiply them unless they're the same root. So the way around it, if they have like bases, I force the roots to be the same. I make the LCD. It's neat. So I get x to the 3, 6, 2, 6. I get x to the 5, 6. See, this is 6th root.
6 root x to the 5th?
Yeah, good. 6th root of x to the 5th. Yes, ma'am.
So you can't multiply number 2 because they don't have like bases? So
You can't, number 1 you could do because they have like roots. Number 3 you could do something because they have like bases. Number 2 has got not like an A. Can't do anything for it. Yeah.
If a problem starts out like that, would you want it written the last way you wrote it, or like x to the 6 is okay?
If I don't say, normally if it starts with radicals, then you should really write it as a radical. So it's good to pick up on that. But if I don't say, I don't care. Yeah. Cool. Because these really do mean the same thing. If math would have been invented in a slightly different order, we might never have even had this symbol. Because we don't need that symbol. That means the same thing, right? We never would have had a radical symbol. But, didn't work out that way, so we do. It'd be a really weird use of a time machine.
This is 12.3?
Yeah, this is 12.3. Another little thing that is really the same way, but let's see how it says. You do it, Jeff. We saw this on that paper, but I want to show you a slightly different way to look at this. If I had square root of 6 times square root of 2, let me just show you, that would be the square root of 12, and then you can simplify that. But watch another way to look at this. What does 6 have in it? 2 and 3. So if I multiply by another 2, I'm not going to have 2 2's. So it'll be 2 rad 3, right? Or you can just make this square root of 12, which is square root of 4 times square root of 3, which is 2 rad 3. So you can just pay attention to what is that other piece bringing with it. Is it giving me more or something I already have? And blah, blah, blah. Or you can just do the damn thing. Right? Make it 12. Break it up. All right. Cool. Make sure I don't miss anything. Oh, all right. Let's do this. We talked about this earlier. Now I want to make sure this makes sense. Say I have the 4th root of x to the 8th, y to the 11th, z to the 33rd.
So I divided by 4 students.
Yeah, so now the nice thing is the shortcut. Yeah, 4 goes into 8 twice with none left over. Good, so there's no x's inside the 4th root. 4 goes into 11 twice with 3 left over, and 4 goes into 33 8 times with 1 left over. Cool. And just to show you, if you don't like that shortcut for some reason, the shortcut just kicks so much ass. But just to show you why it works, you can rewrite this as 8 is nice, 11 sucks, so I'll make it 8 and 3, right? Do you see that? 11 sucks, let me make it 8 that I can do and 3 that I can't do. 33, I can do 32, which means there's 1 I can't do. So this, and this are doable. That's where the x squared, y squared, and z to the 8th came from, right? And then what's left on the inside? Y cubed z. I mean, that's why that shortcut works. Because the remainder would be the extras. Okay. Some of you guys understand, but you always have a pained look on your face, man. All right. So a little preview of what's to come here. No, that's not, believe it or not, that's not until chapter 13. So based on what we've discussed so far, what do you think you could do with this? And this is looking into 12:4. You do it, Jeff. And to do this the quick way, or to do this the longer way, it's up to you. I'd rather do it the quick way. So when I multiply two radicals, I can go ahead and multiply the insides if the radicals are the same. Division is multiplication. They're the same thing. So they act the same way. So I can divide these two if the radicals are the same, and they are. So what's 24 divided by 3? 8. And what's the root of 8? 2. Now the longer way is to break 24 up as 8 and 3, and this is a little bit longer. And I'd rather just attack it directly. If the radicals are the same, you go ahead and divide. So if I had something like this, you can do it, Jeff? Can you? Yes. No? Thanks for the vote of confidence. I like that part. Cool. This would so suck to do it the breaking it up way. Oh my God.
Divide us and strike the
Yeah, just divide, simplify. So let's see, 50 divided by 2. 25. The rad's still there because I haven't done it yet, right? How many x's are left? Where? There you go. How many y's are left? Where? Sweet. And the last thing you do is do the square root. So as long as the roots are the same, you're allowed to simplify the insides, and then the last thing you can do is whatever the root wants to do. Yeah?
So then you do that to the 25 or the 55?
Yeah, everything. I'm square rooting everything. Square root of 25 is 5. Square root of y to the 6th is y third. Square root of x4 is x squared. Cut them all in half, right? Just cut them all in half. Okay, maybe. So what about this here? You guys do this. I like that one. Ooh, that looks. Ooh, that's so easy to make a mistake. It's awesome.
Yeah. Stock one.
You can totally do it.
There is a big.
Same base. How did we handle that earlier? We had the same base.
Why?
We rewrote them as fractional powers.
Okay.
Because then when you divide, what do you do with powers?
You just put-
Yeah, subtract. So that's the process. If the root's not the same, you go, well, is the base the same? If it is the same, you can rewrite them as powers and attack it. If they're not the same, you just stop. You know, it's not shit I can do.
So with that answer, why
Let's see. I don't know. Let's find out. So if I rewrite them, the top will be what? Y to the 4 over 3. Good. Y to the 4 over 5. Roots on the bottom, right? And then you need LCD. So this will be times
20 over 15.
Yeah, 5, 3, so you get y to the 20 over 15 minus 12 over 15. So you get y to the 8 over 15. Yes. And you can write that as 15 root y to the 8. Good.
Can we just multiply the index and add?
Oh!
Can
No, it's a coincidence because of the way the numbers are. In general, you can't do that. So it is just total coincidence that 4 and 4 is 8 and 5 times 3 is 15. It sucks when that happens. It's just the way the numbers are. It's a coincidence. You can't make that into something. Oh, I can always do that. No. So I'm glad you noticed that. I'm like, no, that's not the rule. But I like that you're looking for a shortcut. Good. Just don't find imaginary ones. The last thing we'll do, and then we'll get out really, really, really nice and early. I want to show you a couple things in the calculator that I showed a few of you guys as I was walking around the room. What's up? Find somebody near you that has. Does anybody have a graphic calculator with them? A few of you guys do. If you don't, you can just watch. Cooperate with me.
The blazing speed.
This was a blank check.
Very true.
When a kid finds it, kids check with his grandma.
No, he,
Finds
he's,
something.
he's like a driver over, billionaire
All right,
runs
cool.
over his wife.
All right, guys, so
One check, and then he like, takes all his money, takes all his money.
a really good question somebody had was, how do you do like the third root of something?
You hit math and then you hit.
So let me show it to you in steps. You now know, like if I wanted to do the fifth root of 8, and just get a decimal approximation, I could do 8 to the 1/5, right? Isn't that the fifth root of 8? We know that now. The fifth root is a 1/5 Oh, that doesn't look good, Jeff. Hey, there it is. So I can just do 8 to the... Now, why do you think I put this in parentheses? If I did this, 8 to the 1 divided by 5, that's going to do 8 to the first, and then divide that by 5. So that's going to be complete crap. Right? It's funny that it comes out really close. You guys semi with me here? Now, a better way to do the fifth root is you actually have what I call the throot button, number 5. So watch this. If I do, you got to plug in the root you want first. That's why I call it the throot button. So you hit 5. So it's the 5th root, the fifth root. Now if you have a newer calculator, it actually puts a 5 up where the X is. But, you know, too bad for me. Fifth root of 8. Same thing, right? Do you guys see that? So if I wanted the 7th root of 141,000. Oh, it's 14,100 or whatever. There it is. Huh?
One more time.
Oh, sorry. So if I want the 6th, it's number 5 here, right? So just say number 5. 6th root of 99. There it is. What does that mean?
You don't want decimals, right?
So again, I might, the only time I would want to see decimals on an answer is if I say use your calculator to find the 6th root of 99. And then I'll say round to the nearest thousands place or something. Right? Otherwise, there ain't no damn way I want to see. I want you to do like you've been doing and simplify it, right? One more thing I want to show you. If you wanted to graph the absolute value of something. So here's an interesting one. Let's do something you don't normally see. You know that x squared is going to look like a parabola. Especially if I change my window. Zoom 6. Oh, I got some data in there too. Yay. Right? Guys. Hey, guys. X squared minus 4 looks like a parabola that's been moved down by 4, right? That's amazing. Your absolute value button is in math none. There's your absolute value. Bam. So you could do the absolute value of x squared minus... Now listen, what's this going to do? So that parabola dipped below the x-axis. Absolute value makes anything that's negative, it makes it... So it's going to take that middle part and just flip it up. It's going to look like this. It's going to look kind of neat. Because it's going to take that middle part and what? Boom, boom. Right? So it just took the middle part and went, as it just forces it to be the absolute value. It forces it to be positive. You guys kind of with me here? Just in case you want to do some graphs or something. Or just in case some crazy person asks you to graph in your graph calculator.
Side note, which one is the B? Which graphs?
Oh, good. The reason this one's curved is because, why? Why is this curved?
Oh, x squared.
Yes. So if I just take the square away,
That's a B.
I get a nice V. Yeah, cool. I like it. V for Victor. All right. Wow. This is the earliest I'll ever let you out of here. But it feels right.
It's Friday.
It feels right. It's technically Friday, yes.